So 2022, sorry. This may be expressed as, so this is a repeat question, and the answer for this would have been with the minus 2xy, which is A. The statement, if P, then P and Q. So this is a tautology. Now, what you can do for this, you can create your truth table, and truth tables are easy to create. Create a truth table for it. If P, then P and Q, and you'll see you'll get all truths. Number 3 is a repeat question. It is raining and the sun is shining, but there is no rainbow. Will be and there is no rainbow. So and not are. Let me check and see. Calculator time. Again, some of our calculators could actually work out the third form for this. Mine can't. 3 root 20 minus root 45 plus root 80. We're going to get a positive number, positive 15. I know A and B cannot be it. C looking like it, you know. Root 5 is between 2 and 3. So 7 root 5 looking like 15.65. C. Given that x is less than y, this is a repeat question. We had to go through all. We know that the modulus of anything is always greater than 0. There's a repeat as well. We're going to get 4t to the power 4. This is also a repeat. Change the base. We're going to get log 16 to base 2, which is 2 to the power 4 to base 2, over log a to base 2 is equal to 5. Rearrange, we're going to get 4/5 to be the answer. I can't remember if this one was minus alpha on 3 and alpha on 4. I know that how it reduced when we bring the quadratic in terms of h. We would get alpha squared minus h alpha minus 12h squared is equal to 0. Bring this in terms of h to get 12h squared plus alpha h minus alpha squared is equal to 0. Use the quadratic formula, minus b, which is minus alpha, plus or minus the square root of, and now we will get 49 alpha squared, so we will get 7 alpha, all over 2a, which is 2 into 12. So let me check and see which one would have given us the minus. So we will get minus 7, which is minus 8 over 24, which is minus alpha on 3. A is the answer. The range of this, there's a repeat question. The answer for this was C. If you remember, for the range, to get the domain, we have to get the inverse. Given that f of x is 3 to the power of x, f inverse x is, so that y be equal to 3 to the power x, interchange x and y. ln x is equal to y ln 3. It doesn't matter if you use ln or if you use log. The name of the log just going to be different. And y is equal to ln x over ln 3, or log x over log 3. The answer is A. Which of the following graph best represents the function modulus of 3 over x? The answer is D. The range of f of x is, now the range of a function is from the biggest point on the function to the smallest point on the function. For quadratics, if they do give a domain, all we have to do is calculate the minimum or the maximum point, and the range will be less than the maximum, less than or equal to the maximum, sorry, or more than or equal to the minimum. So this here telling me that that is my curve, we have a minimum point. So I'm looking at y is greater than or equal to something. So it's either this or this. So let me check and see what the minimum point is going to be. So we're going to get 2x minus 5. and the x value for the minimum point going to be 512. Now when x is 512, we go get the y value of the minimum point by substituting 512 into the function. An easier way to probably do this is to complete the square if that is deemed easier in your eyes. 512 squared, 512 squared, minus 5 into 512 plus 6. Minus a quarter is the minimum point, so I'm looking at A to be my answer. So 2 roots of the cubic is this. The third root, I believe we would have solved this on the calculator to get 3 over 2, which is 1.5. So move 2, 3, 2, 3, minus 5, and minus 6. Solving minus 2, 1.5, which is 3 on 2. This is another repeat question. So we bring the 3 on top, bring the 2 on top, and express 1 as log 2 to base 2. So we go in and get log of 2 to the 4 to the 8 cubed over 9q squared multiplied by 2. So we're going to get 16q over 9. The answer is A. Which of the following intervals is in the domain? So we know that our x cannot be negative. So the only one that gives us this answer is B. This is a repeat question. And just by glimpsing it, I can tell it's a repeat because you all will see with the practice going up the years how much repeats we were going to get. This one here is a repeat. I think this is cos 2a, you know. So when you're unsure, let me do the solution. I'm going to assign a value for A. Do we have A stored in our calculator? No. All right, so 0.1258 something, so right? And I'm going to store that in A. 1 plus cos to the power 4a minus sine to the power 4a. 1 plus cosine a to the power 4 is equal to, take away sine a to the power 4. 1.966. 572005. Let me check and see what cos 2a is. Cos 2a is, no, it's not. What is 1 plus cos 4a? Nope. 2 cos squared a? One 1.966570005. 2 cos squared a is the answer. Alright, so I wasn't sure. I thought the answer was cos 2a. Alright. And yeah, I'm not really sure. Alright. This has a minimum value of negative root 89. It's a repeat. This is also a repeat. This was A. This was the one where we let theta be 31 in the previous year. Alright, sine squared x minus cos squared x over tan squared x minus 1 is... Alright, that will be cos 2x on top over sec x below. Nah. I'm going to go through my good old-fashioned substituting the value. So I'm going to get sine A. I'm using the same value of A. Squared, take away cosine A. Oops. Open brackets. Cosine A squared is equal to that divided by open brackets. Open bracket. Tan A all squared minus 1. Close bracket. 0.983286002. 983286002. Where's cos squared A? Cos A squared 0.98362 yeah, cos squared x. Easier way to do this, the numerator is cos 2x. So you could go ahead and do that, and the denominator, tan squared x minus 1, that is going to be sec squared x, I think, right? But you could just put cos 2x on top and use that on the calculator instead of sin squared x minus cos squared x. All right, given are the vectors that the length of the vector PQ is, this was the root 50 question, 5 root 2. So let me just double check and make sure, right? PQ is minus OP plus OQ, which is going to be minus 2, 1, minus 8. Yep, it's the same question. Minus 1, 4, 4. I'm going to get minus 3, 5, and minus 4. That is root 50. 9 plus 16 plus 25. Yeah, 5 root 2 is the answer. Intersect at 3 points. The y coordinates of these points are, I believe this is minus 2, minus 1, and 3. Let's check it and see, right? I'm solving for y, so I'll substitute x is equal to 6 over y. So I'll get y squared is equal to 6 over y plus 7. Y cubed. Bring the 7y across, it becomes minus 7y minus 6 is equal to 0. Mode 2, 3 from a cubic calculator. 1, 0, minus 7 and minus 6, minus 2, 3, and minus 1 is the answer. A curve has equation this. The equation of the tangent to the curve at the point 0, negative 3 is now in unit 1 we don't know how to differentiate implicitly. Bring that across. A curve has equation this. No, we didn't do implicit differentiation in unit 1. So why did I bring a question like this for? Alright, so after much deliberation, I'm going to show you all how to differentiate implicitly. Believe it or not, we have been differentiating implicitly all along. If I have y is equal to 2x cubed, when I differentiate, I'm going to get dy dx. Now, I did differentiate implicitly here. I differentiated y with respect to x. So when I differentiate y, I'm going to get 1. But because I'm differentiating a variable other than x, and I'm differentiating with respect to x, I must slap on a dx on it. For example, a ddx, sorry. For example, if I want to differentiate 4y cubed, that's going to be 12y squared, and I have to differentiate a dx onto it. Whatever variable I differentiated needs to go here. So if I differentiated y, y needs to go there. And I'm differentiating it with respect to x. Let me pick a different variable. Let me say I differentiated 16t to the power of, let me do it, 6t to the power 4 with respect to y. Alright? I differentiated normal. So this is going to be 24t cubed, but I'm differentiating with respect to y. And I differentiated a t variable with respect to y. That is basically, in a nutshell, what implicit differentiation does. We are allowed to differentiate other variables in terms of a different variable. So I could differentiate y in terms of x. With respect to x. I could differentiate t with respect to anything else. T with respect to y if I wanted to. So if I have to differentiate implicitly here with respect to x to get dy dx, right? So when I differentiate x cubed, I'll go get my 3x squared. Take away. Now, Inside here is a product rule because I have a product of two functions, x and y. I must produce the product rule. So the product rule, I'm going to say v is 4x and u is 4x and v is y. It's going to be v du dx. I differentiate in 4x with respect to x. I'm happy. I go get 4. Plus u, which is 4x. dv dx. I'm differentiating y with respect to x. When I differentiate y, I'm getting 1. And I must slap on the d dx on it and the variable I differentiated, which is y. Plus, differentiate the y cubed, I'm going to get 3y squared. I differentiated y with respect to x, so I must slap on the d dx on it, and I must attach whatever variable I differentiated, which is y, is equal to 0. From here is to expand and rearrange to make dy dx the subject of the formula. So let me do that. Let me say 3x squared take away 4y take away 4x dy dx plus 3y squared dy dx. So I'm going to factorize one time and rearrange, right? dy dx is equal to, I'm going to move the 3x squared and the 4y on that side. I'll get 4y minus 3x squared. When I factorize the dy dx, I'm going to get minus 4x plus 3y squared to divide by. They say they want the equation of the tangent to the curve when x is 0 and y is minus 3. So when x is 0, you go away and you go away. When y is minus 3, I'm going to get 4 by minus 3 is minus 12. And 3 by minus 3 squared, which is 3 by 9, which is 27. 3 could go into this 4 times. 3 could go into this 9 times. So minus 4 over 9 is going to be the gradient at that point. That point is also the y-intercept. So I'm looking for a gradient of minus 4 over 9. And I'm looking for a y-intercept of negative 3. The answer is D. I really don't understand why they brought an implicit differentiation question here, and I'd not seen anywhere else around this. Alright, so 24 is a repeat. The only one of these options that is a unit vector is going to be part D. A circle is defined as this, the gradient of the normal to the circle. So if I'm not mistaken, this gradient would have been 0. Let's do it over. The center is going to be minus 2, 0. And the radius, yes, we drew this one here. Minus 2, 0 is here. 0, 0 is the is a point. So this is the center, that the point. The gradient at that radius is going to be 0 because it's a horizontal line. The circle with equation, right? This is a repeat question, but I can't remember what the answer was. So I know the x squared and the y squared will go away. I'll get minus 2x plus 8x, which is going to give me 6x. Minus 6y plus 8y, going to give me 2y. Minus 30. Divide everything by 2. I will get 3x plus y minus 15. The answer is C. Alright, this is kind of a repeat question, but not really. A vector equation of the line which passes through the point 2, 0, minus 6. So that is where I am going. So I must go to the point 2, 0, minus 6, which is 2i minus 6k. So the only one that goes to 2i minus 6k is D. And just to complete the question, I must go in the direction of the vector and is parallel to V. So they actually use the vector V as itself here, right? So that's no problem. Cool. So the answer is D. Set of values, right? So I know that it was minus 6 and 2. The vector A is given by this. A unit vector parallel to A is this here. 5 squared and 12 squared is 169. Square root of 169 is 13. And it's going to be 1 over 13. 5i plus 12j is the unit vector. That's a maths question. The angle between the vectors is, now they give the angle in degrees, so let me dot product it, calculate the magnitude of each vector and see what is seen, right? So u for minus 5, 1, dotted with 3, 6, minus 1, 12 minus 30 minus 1. I can't be too sure. I'm gonna check it on my calculator. 12 minus 30 minus 1 minus 19. The size of the vectors now, let me get in the mix, right? I'm going to get 4 squared plus 5 squared plus 1, which is 16 plus 25 plus 1, root 42. 9 plus 36 plus 1, root 46. So 46 by 42, I just making life a little bit easier. Minus 19 over root 1932. And it's cos inverse of this. I am currently in radians, so I'm going to go back into degrees, and I'm shucks. Minus 19 divided by, I got to go through it, root 42, and I divide them by root 46. Cos inverse of this, 64. Oh, this is the positive angle. Cosine of this is, give me back that. I forgot to put the minus 19, so I got to put the minus 19 there. And cos inverse of this is 115.61. So it's E. Alright, so I just forgot to put minus 19. This one is 48 root y. Tan 5x, when I differentiate tan again, sec squared, and I'm multiplying by the differential of the angle, which is going to be 5 sec squared, 5x. Given that y is equal to that dy dx is, I not, like I said before, I not going to bother differentiating for x cubed. All of the answers, options are the same. I'm not going to bother differentiating sign. Alright? Actually, I have to bother because it's either 18 or 108. So I know when I differentiate and I had to multiply by the differential of the angle. So 6 3s are 18, but I had to differentiate twice. So it could be 18 multiplied by 6, which based on the answers has to be 108. So now all I want to know is if it's going to be a positive or a negative as my answer. When I differentiate sine, I get cosine. Then when I differentiate cosine, I get a negative sign. So this negative sign persists through here, and then the negative sign persists. So I'm going to get a plus as my answer. The answer is D. This is a repeat question. This was number 44 from the last year paper. Limit as x tends to minus. That looking like minus 4 to me. So let me check and see if the denominator given me something that is, well, if it given me a 0. So I'm going to get 16, take away 20, plus 20 actually, because it's minus 4. Alright, so L'Hopital up the place. 2x minus 2 on top, 2x minus 5 below. Plug in minus 4, are going to get minus 8 minus 2 is minus 10. Minus 8 minus 5 is minus 13. Minus 13. 10 over 13 is my answer. The volume of the solid generated when the area enclosed by the curve y is equal to x squared. Y-axis is rotated about the x-axis. Sorry, is rotated about the y-axis is the integral of pi. The y-axis, it will be x squared dy. So it's going to be pi y dy, which is pi y squared on 2 between 4 and 0. 16 on 2 is 8. I know it's a repeat. I just double checking to make sure the answer is correct. So same thing I will do for this question that I did in last year. I'm going to get the sine theta and cos theta to be the subject of the formulas and square both sides, incorporate my identity, and get my answer. So I'm going to get x over 4 is equal to sine theta, square both sides, x squared on 16 is sine squared theta. Same thing, y squared on 9 is cos squared theta. Add both of them together, I'm going to get x squared over 16 plus y squared over 9 is equal to sine squared theta plus cos squared theta is 1. Multiply everything by 144, I'm going to get 9x squared plus 16y squared is equal to 144. So given that y is equal to cut of 2x plus 1. Now when I differentiate cut, I put in this here for all to remember it, right? The differential of cut x is going to be negative cos x squared x. Obviously, as we have the rule, whenever we differentiate in a trig, we must always multiply by the differential of the angle. So I now get negative cos x squared x, and the only one that gives me negative cos x squared is a. Just confirm, I have to multiply by the differential of the angle, which is 2. So negative 2 cos x squared, 2x plus 1. This is a repeat question. I believe it's x squared into, I know it had an x on the cosine. Both of them have an x on the cosine. So I can't remember which one it is, if it's minus 3 sine x or plus 3 sine x. So I'll go through the working. This is u, this is v. V by du dx plus u by dv dx, which is minus, no I lie, which is cosine x. So it's only pluses in the mix, right? So if it's only pluses in the mix, the answer is D. Alright, so now I got the x by the cosine here. For which of the following values of x is the function discontinuous? Minus 5 and minus 3. Just put the denominator equal to 0 and solve. Minus 5 and minus 3. Alright, equation of the gradient of the normal. So the gradient of the tangent, when I differentiate, I get 1 on x. The gradient of the tangent is 1 on 2. The gradient of the normal will be minus 2. This is a repeat question. I believe this is minus 20 because we had 20 take away 40. Let me just go back in the previous year to confirm and verify that this is indeed a repeat question. I know it's a repeat, but to confirm that that is indeed the answer. That was one of these previous questions here. I doubt it was so far up. Okay, I know it was from the last year, right? Or was it from the year before? Because we're doing these things with so much of speed. Okay, looking like it's from the year before this. Okay. Yeah, it is from the year before this, right? So just confirming y is equal to minus 5 into 1 minus 2x squared. We're looking at the derivatives. We're looking at the chain rule. And then we plugging in the value of x, which is going to be 1 to get minus 20. So just confirming, watch it good and see. Minus 5 into 1 minus 2x squared. 2022. Minus 5 into 1 minus 2x squared. This is also another repeat question. This is going to be part D because we need to integrate x with respect to x. I cannot integrate x with respect to y like here. I can't do that. D is the answer. Alright, so cos cubed of 3x squared minus 1. This is a chain rule inside of a chain rule. G's and H's. This is pressure. Alright? So what are we going to tackle this one? So we're going to get cosine of 3x squared minus 1 all cubed. When I using a shortcut to the chain rule here, which is going to be a chain rule inside of our chain rule, right? I'm going to get 3 into, actually it's not chain rule, it's just one chain rule. Cosine of 3x squared minus 1 squared multiplied by the differential of the function. When I differentiate cosine 3x squared minus 1, I'll get minus 6x sine 3x squared minus 1. Let me fix it up. Minus 6 by 3 is minus 18x. We're going to have cosine squared of the function and sine of the function. So minus 18x, cosine squared of the function and sine of the function, the answer is D. The gradient of the normal to the curve, 6x minus 2. When x is 1, I'm going to get 6 take away 2 is 4. That the gradient of the tangent. Gradient of the normal is going to be negative a quarter. And that is it for 2020.